Here are your answers to last night's homework, Unit 10, Day 3. Please check your answers. Make any corrections needed. On the next few pages, you'll see that I have copied my work and have posted it. So you'll get to see the work that goes with this as well. So please be sure to make corrections. Remember, your homework packet might be collected for over winter break. Okay. Here are the answers to the first few questions here. Here I wrote, this is the only way to put a quadratic into vertex form. You don't need to worry about that right now or what that means. That's the day 4 notes that we will be getting to when you get back from break. So right now, we need to know how to complete the square because basically not all quadratics factor. And you cannot use, you haven't learned how to use quadratic formula until today's lesson. And some of your directions might just say complete the square. Remember, b divided by 2 squared. That will never be supplied for you on a formula sheet. You need to know that. Explain your process. So I just listed step by step, line by line, what I did. Keegan's yelling at the dog. She's snorting. I don't know what she's doing. Off to the side, make sure you show your B work. Don't skip any of it. People were making mistakes with that yesterday. All right, let's go to the next page. I said to write your answer in simplest radical form. So once again, isolated the constant, figured out my B work, added that to both sides, wrote this as a factor of perfect squares. Remember, it's always that number right there will always be your perfect factor. Square root both sides. When you square root the right, because you got an equal sign, you have to take the plus minus. And then, once again, isolate your x. The next one. And if you need to pause, go ahead and pause the video. Over here, same idea. Isolate your x's. Do your b work off to the side. Your b work gives you a +1, so we added the +1 on both sides. And that makes this so it's factorable. Perfect factor. Factors of 1 that add to -2 are 1 and 1, so we get x plus 1 squared. We want to get rid of this now, so we square root both sides. Remember, this is all from day 1 notes. So if you're having an issue with these last 3 lines here, go back to your day 1 notes. And that's the answer to number 5. Number 6, you saw before, it was just choice 2. on here, I want to show you, there's another way you could have done this. You could have typed this into your calculator right here under, say, F1. Okay, so type this in your graphing part of your calculator. And then you could type each of these into your calculator. However, when you type things into your calculator, you can't put an equal sign. So if I took this and went to my graph, and I typed that first, so x squared minus 8x minus 7, x squared minus 8x minus 7, enter, there's the graph. Now, because this is multiple choice, you're going to be able to back into this problem without really being able to complete the square. I could type this into my calculator. However, I can't type this in with the equals 9 in here into my F2. For F2, what I would have to write now would be, I would have to get this over there. So for that 9 to go to the other side, it would be minus 9, minus 9. So in my F2, I would write x minus 4 squared minus 9. Now let's type that into our F2 and see if it graphs on top of it. Oh, that's so nice, how maybe. F2, so we're going to type this in right here. Squared minus 9. Those do not lie on top of each other, so that's not our choice. Well, how about we go to, I did completing the square. I did the work. So this one, to get this alone, to put that in my calculator, I would have to go like this. X minus 4 squared minus 23. Let's type that in and see. Oops. So what is it, minus 23? Yeah, it's written right there, silly me. I enter. Oh, look at that. Well, it's right on top of it. So therefore, that is the multiple choice that works. So if you forget how to complete the square and it's multiple choice, remember there's more to one way that usually solve the problem. And there we just used our calculator, especially because it's multiple choice. We didn't have to show any work. All right, next problem, number 7. Same idea. So I did negative 5 halves squared, because that's your B, squared equals 25 fourths. Or no, sorry, I worked backwards. I took this and worked backwards. So you could take each of these, complete the square, and see which one gives you this, or you could do like I just suggested on the top and type each of these into your calculator, see where they graph, and then see, you would have to type into F1 x minus 5 halves squared minus 13 fourths and see which of these lies on top of this, and it's choice 4. That's probably the easiest way to do that one. Number 8, which equation has the same solution as this over here? I did my B work, got 9. Remember I brought this 12 over. This would be -3 squared, so you get 21. And realize they didn't solve that. They didn't finish it off. So always pay attention to your multiple choice. Okay, what are the solutions to this equation? Same idea. Do your B work. And remember, once again, you could actually set this equal to 0, graph it, and then find the decimals where it hits the x-axis, and then round these and see what decimals it is equivalent to. All right, so that was the homework. Please make sure you're making corrections. If you need to pause or go back, please do so. Okay, so now we're gonna go on to our little lesson. Remember, we're going back to Unit 9, Day 2. Make sure you do the Day 2 homework tonight. No excuses, it's due for everyone. Unit 10, Day 2. Unit 10, Day 2 homework due tomorrow. Test tomorrow. Okay, the quadratic formula right here. And someplace I have, if you can recall, you get that on your formula sheet. Here it is. All right, so remember, you have this fancy, nice sheet. On your Regents exam, it's just going to be one of the last pages in your exam. It's not going to be yellow and nice like this, but the quadratic formula is right here. It's supplied to you. All right. So there it is. Write it down. Okay, now make sure you write this down. Do not forget the x equals. So I highlighted it right there. You are solving for some variable. It's not always an x. You could have t for time or d for distance. They could change the variable. But that should be the only variable you should be solving for that will end up in this quadratic formula. That will be your only unknown. The rest of these, you're going to fill in with numbers. Okay, so your A, your B, and your C will all be coefficients in your quadratic, from your quadratic equation. Realize there's a difference between the quadratic formula, the quadratic equation. This is the formula. An equation can be any x squared equals whatever. The formula is using this formula to find an answer. And why do we need the quadratic formula? Okay, most quadratic equations cannot be solved by factoring, and you do not learn how to complete the square if your A is greater than 1. In this course, that is. Therefore, typo, the quadratic formula is your go-to. So if your A is greater than 1, you can't use completing the square. And most quadratics don't factor. So we have to use the quadratic formula. We don't have any other option. And if you don't like factoring, or completing a square, the quadratic formula, it always works. Okay, there are 3 things you have to make sure that you have before you can delve into the quadratic formula. So make sure you have a quadratic function and standard form. Okay, so standard form means, technically it means your A has to be a positive. However, with the quadratic formula, right here, it does not matter if you substitute in a negative value. It's fine, no big deal. But standard form does mean that you have a value of positive. So that part I put in parentheses because technically that's what standard form means, but the quadratic formula really doesn't care about that part. But you do have to have a quadratic function. You have to have descending order. So your highest exponent, so which should be a squared, to no exponent. And it has to be set equal to 0. All those 3 things. So you can't use the quadratic formula for a linear function or a cubic function, not that you would do those, but, and this is to solve something. Okay, so let's go on to an example. All right, solve this. Solve x squared minus 3x minus 18 equals 0. But before that, let's make sure our 3 qualifications for standard form are met. So check to see if this function is a quadratic in standard form. It's a quadratic, has an x squared. Our a here is positive, not that it matters for the formula. Descending order, it goes from squared to x to our constant. Remember, I like to have that little drawing right there like this. That's a crooked triangle there, but from highest exponent to no exponent. So 2, 1, nothing. So that is descending order. And then it is set equal to 0. So all of these qualifications are met, therefore we can proceed. Okay, we're going to solve this by factoring, just like we did in Unit 9. And then we're going to solve it by using the quadratic formula. So, all right, by factoring, we're looking for, I have to move this camera now so I can write on this, and you can see, if you saw this contraption, you'd wonder what the heck was going on. Let me see. Okay. So we're looking for factors of negative 18 that add to negative 3. Remember, this is from your factoring tree. There is no GCF. We take down this middle path because there's 3 terms. A is equal to 1, so therefore we read backwards. Factors of negative 18 that add to negative 3. Factors of negative 18 that add to negative 3. So if you need a list, go ahead and write them down. 1 times negative 18, 2 times negative 9, 3 times negative 6. Well, right there, those add up to negative 3. So those are my 2 factors that will solve this, that will be the factors or the roots of this equation. So I'll do x plus 3, x minus 6. Make sure you don't drop that equals 0, otherwise we're not solving for anything. That was a common mistake on your test. We're going to take each of these now, set them each equal to 0, so x plus 3 equals 0, x minus 6 equals 0, get your x alone, negative 3, get this x alone, we get 6. So solution set, negative 3, 6, which is good. We had a quadratic, so we better get 2 solutions. All right, so that means if you were to graph this, it would cross at negative 3 and positive 6. 3, 4, 5, 6. Okay, so right there. We also know that this is a concave up because the A's value is positive, and we also know that it crosses way down here at negative 18 because our C value, remember, is negative 18. Well, it should probably be. All right. So we're now going to do this problem, same problem, but using the quadratic formula. Now, the quadratic formula isn't always the most efficient way, but sometimes it can be the easiest way, especially if your factoring skills are lacking. All right, so here we're going to have to find out all your coefficients. Remember your A, your B, your C. Here's the quadratic formula again. Remember, it is on your formula sheet, so don't mess it up. Make sure you copied it down, double check, don't get it wrong. And also, write it down on your notes or your homework or whatever you're doing, because if you make a mistake with that but substitute correctly, we can give you partial credit. So we have to identify the A, the B, and the C that are values that need to be substituted into this. So if you remember, the A is the coefficient that goes in front of your x squared. So our A is 1. Well, let me see if I have colors here. Our b is the number in front of your x term. And you take the sign with it. So our b is -3. That's hard to see, I realize that. And our c, oh, can you even see that one? I don't think you can. C equals -18. Well, that's not gonna work, is it? Hey, Stinky Stella. All right, we're gonna take those in. We're gonna substitute them into this. Make sure you don't forget to have x equals. You need to solve for something. Wherever there was a variable here, I'm going to put a set of parentheses. So negative, set of parentheses for the b, plus minus, square root. There was b there, so I'm putting a set of parentheses. Minus 4a, gets a set of parentheses. C, set of parentheses. All over 2 times a, set of parentheses. Wherever the a was, so there's an a here, if you notice, and an a here. I'm gonna put 1s in there, a 1 and a 1. Wherever there was a b, right here and right here, I'm putting -3s in. -3, -3. That's hard to see, isn't it? And then your c is right here. We're going to substitute in your -18 there. Now this only becomes an order of operations problem. PEMDAS, remember? Please excuse my dear Aunt Sally. I don't know what Aunt Sally does. Negative times a -3 is +3, plus, minus. You're going to take all that stuff underneath. You're not going to square root it right now. You're going to turn it into one integer. So if you're not good at order of operations, we'll use the calculator. And of course, we will use parentheses. Okay, so I'm just typing this part in. So I'm going to parenthesis, -3, close parentheses squared. I don't know what Stella's doing. 4 times your a, which was 1, times our c, which was -18. Close that up and hit enter. See what we get? 81. So right here, we have square root of 81. If you remember your perfect squares list, I hope, or you created it, 1, can you see that even? Okay, 1, 4, 9, 16, 25, 36, 49, 64, 81. 81 is on our list. It's the 1, 2, 3, 4, 5, 6, 7, 8, 9th number down if you didn't know that already. So the square root of 81 will be 9. So we're going to say x equals the 3 that's out there plus minus the square root. Oops, sorry, no square root left over because it was a perfect. So 9 all over 2. I'm going to do this math up here. Remember, you have 2 problems now. X equals 3 plus 9 divided by 2. And x equals 3 minus 9 divided by 2. So this will be, that's 12 divided by 2 is 6. So 1 ugly 6. And this would be -6 divided by 2, which is -3. Same answers as we got over here earlier, isn't it? So we could put those in solution sets now. 6, -3. Remember, the order of those does not matter. And there's your solution. Sorry, I couldn't see all that. There's a -3 there. It's hard to see. All right. So it doesn't matter if you use the quadratic formula or factoring. Both ways, we got the same answer. We could do this by completing the square as well and still get the same answer of 6, -3. No matter how we solve it, it's always going to cross the x-axis at the same spot. All right, example. Solve the following quadratic equations by using quadratic formula. Write answers in simplest radical form and to the nearest hundredth. So remember, when it says to the nearest hundredth or thousandth or billionth place, that would be terrible. You have to use your calculator. And hundredth place means 2 decimal places. And write in simplest radical form means that we're going to use our perfect squares list. Okay, so when it says simplest radical form, oh, this is getting so far away. Simplest radical form, we're going to be using our perfect squares list. So that's when we have to make 1, 4, 9, 16, 25, 36, 49, 64, 81, 121, and so on and so forth. Remember, you could go on forever and ever. Okay, so we have to do both. We have to use the perfect square, and we have to do simplest perfect square and the calculator. So, first off, to use the quadratic formula, if you remember back on the previous or on the top of the page, we had 3 pieces of criteria we had to meet. Set equal to 0. Is this one set equal to 0? No. So this is not in standard form. Okay. Which doesn't mean we can't do it. It just means we have to do some work before we can. Okay, so we need to get this -11 to the other side. So if we bring this over, it's going to come over as a positive. So we'll have x squared minus 7x plus 11 equals 0. Make sure you now have standard form. Our x squared is positive. Doesn't have to be, but it is. It is a quadratic. It has to be a quadratic. We're in descending order. It goes from squared to first to a constant. So we are in descending order. And now we're set equal to 0. So we can use the quadratic formula now. If you don't remember what it is, it's x equals -b plus minus square root b squared minus 4ac all over 2a. And wherever there's a variable, remember, we're going to replace it with a number inside of parentheses. Our a in this problem is the number right out front, so it's 1. The b is -7, and our c is 11. We're just going to substitute those in properly and use our order of operations. So x equals realize that none of these, the a and the b, I do not write the variables with them. I don't put x's with them or x squareds. They're only coefficients. So the b's, I did it. The a is 1, and I know there's an a down here too. And now the c value, so 11. All right, all that It's done. Now I just have to simplify. Negative of a negative 7 is positive 7. You can type this into your calculator and you will get 5. That's 49 and that's negative 44, so you get 5. In this course, in Algebra 1, the number under radical has to be positive. Positive number here. It has to be. Otherwise, it would be an imaginary number. And remember, you're not allowed to touch the imaginary numbers until you go to Algebra 2. State has decided you guys aren't old enough or wise enough, I guess, for some reason, to handle it. I don't agree. Now I'm going to write this with 2 separate fractions. If you realize there's an invisible 1 right here because it's 1 times root 5. So I'm going to break this up like this, and then I'm going to break it up as a fraction like this. So I'm going to say x equals, now this is going to be the exact answer, 7/2 plus minus 1/2. That's that invisible 1 right there that I wrote in red. Square root of 5. So that is your exact answer. We can throw that in solution set. Now I have to find the decimal in my calculator. So I can close out whatever you have in here if you don't like to see it. So I'm going to type this right here in my calculator. Let me erase this. All I really need to have right now is that. So I'm going to put my 7/2. If you like to have the fraction written vertically like that, right above this division symbol, right up there in blue, there is the fraction bar, if you remember. So you can hit Control and then that, and that will give you that fraction symbol if you like to have things written just as they are. And then you can just arrow down. Arrow to the right. Now 7/2 plus minus, you can't do plus minus. Your calculator can only do one operation at a time, so we're going to do plus. I'm going to do my 1/2 now. I'm going to show you, it does not matter if you use the fractions like this or if you use them like this, 1 divided by 2. Calculator does not care. And that 1/2 is multiplying right there. Remember, that's the invisible operation, multiplication. Radical 5. I'm going to hit enter. That is going to be your first approximation. So we can say x is about, remember our calculator right now is only going to 5 decimal places. This, because of that radical 5, is irrational. That can go on forever and ever. Our calculator is limited. It's pretty impressive, but not infinity impressive. And then I'm going to type this in again. Oh, sorry, you couldn't even see that. I'm going to type this in again, but I'm too lazy to rewrite this. So if you hit this arrow button up twice, so once, twice, and then hit enter, it just copies and pastes that down. However, this time I want to do the minus. So I'm going to go arrow over, and then if you notice right here it says delete, so I'm going to hit delete. I'm going to change that to a minus, hit enter, and there is my other. Remember, this is just an approximation because our calculator has 5 decimal places, so that's why I use the squiggly equals 38197. If I go back to my problem, it said write in simplest radical form. We did that, and to the nearest hundredth, which we said earlier was 2 decimal places. So now I'm going to write this as, in my solution set, does that 8 turns this into a 2? 4.62. And, whoops, this 8, you go to the right. Does that 1 have enough power to bump that up? Nope. So we say 2.38. And those are your approximations. Okay, this is the two exact answers. These are the approximations to the nearest hundredth. Let's do another one. Okay. Once again, same thing. Make sure it's a quadratic. Check, got it. Is it in descending order? Let's see. Yep. Goes from squared to the first power to the no power. We're good. Then, is it set equal to 0? Check. All 3 things for standard form are done, and it's quadratic, so we can use the quadratic formula. So, once again, quadratic formula. There's a song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's a really corny video that goes with it too. Here, our a value is 3, our b value is 4, and our c value is negative 1. Don't tell anybody I ever saying to you. I'm going to substitute those values in the proper positions with parentheses. Don't forget your x equals. Otherwise, it's not like you're solving for anything. Okay, you need to solve for whatever variable you have in the problem. This one is an x, so that's why we have x equals here. All right. We're going to have that fraction bar. I have a negative that always comes with the problem. Plus, minus always comes with the problem. Radical with the problem. This has a lot of problems, doesn't it? Minus 4 times a times c, all over 2 times a. We'll substitute our coefficients in. Remember, the b is first in this formula. B again. The a goes here and here. Our a was 3, so 3 here, 3 here. Our c is negative 1. So all I did was substituted the b, the a's, and the c in from this quadratic equation. That's an equation. This is the quadratic formula. I would not want to use yesterday's method on this problem, the completing the square. I know some of you were big fans of it. However, this you would not want to use completing the square because our a value is greater than 1. You don't know how to do that yet, and we'll save that for Algebra 2. And in Algebra 2, they still have a difficult time doing it. Don't tell them I told you. It gets ugly. Okay, so x equals negative over 4 is negative 4 plus minus. Remember, we're turning this into one integer, and it cannot be negative because we're in Algebra 1. We're limited to the real numbers. So if you're not good at operations, remember, once again, you can go to your calculator. You do not type in that square root symbol. You just type in everything that's under there. So we're just going to do 4 squared minus 4 times 3 times negative 1. And it doesn't hurt to double check anyways. And remember, you know this answer has to be a positive answer. And we get 28. All over 2 times 3, which is 6. If you remember when we first started the problem and I read the directions, simplest radical form, I said that means we're going to be using our perfect squares list. Anytime you have a radical from now on, the rest of your life, you have to simplify the radical. We're going to use your list: 1, 4, 9, 16, 25, 36. I can stop there because my number's at 28. Numerically, in the number line, it fits in there. So I'll do 28 divided by 25. That's a decimal. Don't like it. Equals a decimal. Not good. 28 divided by 16. Decimal. Not good enough for us. 28 divided by 9. Decimal. Not good. And 28 divided by 4. Oh, winner, winner. We got an integer. We got 7. So we're going to say x equals -4 plus minus. We found its perfect square. It had one. The last problem there was radical 5. 5 is not on our list anyplace. 28 isn't either, but there's a factor in there that is perfect. Just dying to get out. All right, so it's 4 times 7 makes up 28. We like the 4 because it's on our perfect squares list. It's the largest perfect square that goes in there. When you take the square root of a 4, it comes out as 2. Remember, any square root, when it comes out of the radical, it will be smaller in size. Not physical size, but as a number. So here, there we go. Now I'm going to break this up into 2 fractions. Don't forget, x equals. So I get -4 over 6 plus minus 2 over 6 root 7. Hope you realize, just like you can't leave a radical 28, you can't leave a -4 6 or a 2 6. Same kind of badness. -2/3 plus minus 1/3. I had to reduce that. Cannot leave that kind of shenanigans. Okay, reduced. That's your simplest radical form. That's the exact answer. If I were going to send somebody to the moon, I'd want to make sure that my calculations were exact. Now, if I'm going to Lowe's to buy some lumber, nearest hundredth is way more than precise enough to me. So I'm going to take this now. I'm going to type it in my calculator and get your answer, your decimal. -2/3. And I'm just going to do the plus 1 first, 1/3. And that's times root 7. Enter. See, I get 0.21525. Make sure you're doing this on your own as well so you can check. Don't just leave me to do the calculator. I'm not the best at it, but you guys need the practice. Then I would hit up, enter. Change this to a minus. Enter again. And that's hard to see, I know. It's -1.54858. And I should say about, and x is about here. It says to the nearest hundredth. So when I put those in solution sets, I'm going to round. This 1 gets rounded to 0.22, and this 4 gets rounded to a 5 because of that 8 there. So that's much more helpful if you're going to graph this quadratic, to know that it crosses at 0.22 and -1.55. This doesn't mean much for us on the number line. All right, so there you have it. Now we're going to take this into a real life problem situation. I just tried to clean my board electronically. So we have a friend who's, whoopsie daisy, sorry about that. Working on a project that involves the path that kicked by a soccer ball. This is my poor representation of that situation. After numerous kicks, she modeled the general path of the ball using the quadratic function v of h equals -0.01 h squared plus 0.6 h, where h is the horizontal distance. So this right here, our horizontal distance is h. So we can label this as our h. And the vertical distance of the ball traveled in meters is your v of h. So right here, I want that thing to stay there. This is our v of h. Okay, vertical distance. Now, if you notice, if she's kicking from right here, the soccer ball is most likely on the ground. And then when it lands over here, it's on the ground. Okay, I don't think she drop kicked it. So we need to write an equation to determine the distance the ball has traveled. Remember, there's 3 things to write a quadratic equation in standard form. You cannot do that, or you cannot use the quadratic formula unless you do that. So we're gonna write this equation right here in standard form. It's already in descending order. You might not like that negative there, so we could change the signs of both these and that would work. You're allowed to do that. But the problem with this is that it's not set equal to 0. So the equation to determine the distance, we have to solve for something. So this would be sufficient. Okay, we had to have that set equal to 0 because that's one of our 3 necessary pieces of or 3 qualifications that you have to be in standard form or to use the quadratic formula. We have a quadratic, we have a set equal to 0, and it is in descending order. And if you don't like working with a negative a value, you could think about this and change everything over to the other side. So you could bring this over here, and you could bring this over here. If you did that, this would turn into a positive, and that would turn into a negative. But the quadratic formula really doesn't care, so I don't either. All right, determine the horizontal distance the ball traveled. So we're trying to figure out how far this distance is from here to here. So the ball landed and it, started off and landed. So is she, should she be playing for the NFL and we should be measuring in yards instead of meters? We'll figure this out. So we're going to take this and take it into our quadratic formula. If you notice though, our a value right now, a is always in front of the squared, so it's negative 0.01. Our b is always in front of the h, to the first power, so it's 0.6. And our c, there isn't a constant, so your c is 0. When you use the quadratic formula, you always have to have a value for your a, your b, and your c. And sometimes it's going to be 0 for your b or your c. Your a, you better have something, otherwise you don't have a square term. Okay, we're going to substitute that. Oh, guess what I almost did? Look, I almost wrote this. Well, let's do it for a second. B squared minus 4ac all over 2a. In this problem, do we have any x's to solve for? No. We have h's to solve for. So that means I have to take this and change that to an h. So on your first page of notes, the first thing the second thing you wrote down, I said that can change with the problem situation. Now we're going to substitute our values in. So h equals negative 0.6 plus minus square root 0.6 squared minus 4 times our negative 0.01 times our c, which is 0, all over 2 times a. All right. Use your calculator there. H equals negative 0.6 plus minus. When you put that in your calculator, you're going to get 0.36 all over negative 0.02. Now, I hope you realize that 0.36 is just like 36. So there's going to be a perfect square into it there. If you take that, and we do square root of 0.36, so
what kind of bread is this?
0.36 it's hard to see, you get 0.6. So I'm going to say H equals negative 0.6 plus minus 0.6. Remember, once you take the square root, the radical's gone, over negative 0.02. This did not say in simplest radical form. We're looking for a real life situation, an answer here. We don't, like I said, you don't go to Lowe's and say, oh, I want radical anything. We get decimals or fractions. We don't leave things with radicals. So I'm going to do 2 problems here. Let me break this up. We're going to have the negative 0.6 plus 0.6 over negative 0.02. And then negative 0.6 minus 0.6 over negative 0.02. We do that. That's going to be 0 divided by negative 0.02. 0 divided by anything is 0. That's going to be negative 1.2 divided by negative 0.02, and that's going to get us 60. So if we go back to our drawing, that means that, yes, she did not drop kick that ball. It was on the ground at 0, and it was on the ground at 60 meters. 0 meters. Determine the horizontal distance. So how far did it take to go from here to here? Well, we're going to say, make sure you show some work here, 60 minus 0 equals 60 meters is the distance. It's a word problem, so word answers is the distance the ball traveled. Okay. Now the next part. Determine the horizontal distance. Horizontal distance just means the height. It's like my horizontal distance is 5'2". It's the weirdest way there's to say it. The ball traveled when it reached a height of 6 meters. Well, no, sorry. Horizontal distance is this, but determine the horizontal distance the ball traveled when it reached a height of 6 meters. So, if you look at your picture, 6 meters doesn't even fit. My picture's not accurate because 6 meters is very tall. She's kicking this thing really high in the sky. 6 meters would happen twice. It would happen right here, and it would happen right here. If, to say this, are 6 meters. She's not 6 meters tall. So, right here and right there. On its ascent and it's on its descent. So determine the horizontal distance the ball traveled when it reached the height of 6 meters. So you could have 2 different distances here. It could be this distance, or it could be this distance. We don't know which one. If you stood right here with a net, you would catch the soccer ball. If you stood right here with a net, you would catch the soccer ball. We need to know where to go stand. So what we do here reached a height of 6 meters. So we had V of H, equals negative 0.01 H squared plus 0.6 H. Now, the height is 6 meters. If you go back to the word problem, the H in this, it says where H is the horizontal distance the ball traveled, and V of H is the vertical distance. Height is your vertical distance. So this right here is your vertical distance. Most common mistake I could see with this problem, would be that people would substitute the 6 in for your horizontal distance and not your vertical distance. That's your vertical distance, which they said is V of H at the top in this problem. So our 6 needs to go right in here. 6 equals negative 0.01 H squared plus 0.6 H. And now we're going to solve. So we have a quadratic here. It's not in descending order, and it's not set equal to 0. It's not descending order because it's not set equal to 0. So we're going to take that 6, bring it over. So we'll get 0 equals negative 0.01 H squared plus 0.6 H minus 6. Remember, it doesn't matter if it equals on the left or on the right. Now, we do not want to try to factor this. Decimals factoring, no thank you. We don't want to use completing square because our a value is not a positive 1. So the quadratic formula is what we're stuck with. Thank goodness, it's so amazing. Our a value here is negative 0.01. Our b value is 0.6 again. This time our c value, however, is negative 6. So that's what's changed in this problem. We're not looking for when we're on the ground. That's what happened last time. We started off at the ground. If you'd realized that, you could have said 0 right away as one of your roots there. And we'll substitute that in. We're not saying x equals, we're saying h equals negative b plus, negative b plus or minus the square root of b squared minus 4 times your a times your c all over 2 times a. And we'll substitute those values in. B goes in the first two. I just like the a so much, I guess. Okay, I'll put the b in here. 0.6, 0.6. 4 times a, so this is negative 0.01. Your c is negative 6, and all over 2a, so negative 0.01 again. I'm not going to do this in my head. Just remember that you cannot get a negative number for that when you put in your calculator. If you did, it means you weren't using your parentheses correctly. Your calculator is only as smart as the user. I type that in. Let's see. Of course, I wrote it right where I want to see. So 0.6 squared. What in the world am I doing there? 0.6 minus 4 times your a negative 0.01 times your c, which is our negative 6, enter, we get 0.12. All over negative 0.02. Now, square root, there, we want this to the nearest, what did it say? Determine the horizontal distance. It doesn't say to round to anything. We're not going to leave a radical because it's not appropriate for this situation. It doesn't say leave in simplest radical form, but a distance for us, we want real numbers. We don't want radical or irrational numbers. So I'm going to do, remember, you're going to have two answers here. You're going to have negative 0.6 plus the square root of 12 over negative 0.02, and you're going to have negative 0.6 minus the square root of oops, I forgot my decimal there. Big difference. All over negative 0.02. All right. Let me make sure you can see those. We'll type that into our calculator. And you will get H equals 1 is 47.32050808, and the other one, I think I didn't use this calculator to do that. H equals, oops, H equals H, of course it does. 12.67949. That's what your calculator would give you. So this, your calculator would give you 32051. So if we went back up to here to the, you would have to stand 12.6 meters away, and you'd have to stand 47.3 meters away from your friend there to catch the soccer ball when it's 6 meters in the air. You must have a really long net there. And it's a word problem, so you would write this in a word solution. You would say the horizontal distance the ball traveled when it reached the height of 6 meters is this and this. I'll leave that to you. Because of time's sake, let's go. Last thing for the day. I know, thankfully, huh? It's been a long lesson. Sorry, I appreciate your struggle. Is the discriminant. The discriminant is the name given to the expression that appears under the square root or under the radical sign in the quadratic formula. So it is only this portion right here. That is the discriminant. There's no radical left. It's just the b squared minus the 4ac. That can tell us a lot of information about the nature of the roots of the quadratic equation. It'll tell us what our picture looks like without even graphing it. So we're going to look at these. Erase, erase, erase. Okay, so it will quickly tell you the number of roots, or other words, the number of x-intercepts associated with the quadratic equation. Now remember, a quadratic is x squared, so technically there are two roots. However, we've done this before. Remember, we could have two roots here. If you see that, there's two roots. Right here and right here. Let me get the red marker. So your roots, remember, are where you're crossing the x-axis. So this has two roots, 1, 2. This has, remember, there is one double root there. Okay, remember, it hits it and then bounces back off. So it appears to only have one root, but because it's quadratic, there are two, but it's called a double root. It's one double root. Okay, one double root. And then the last situation is, look at that parabola. It doesn't even touch the x-axis. Now, it could go like this also. It could be concave down, but never touch the x-axis. It's a renegade there. Okay. Now, if your b squared minus 4ac, your discriminant, is greater than 0, you will always get 2 roots. 2 real roots. Okay, so if your b squared minus 4ac is greater than 0, so if you do this, like here's an example, you don't have to do all this work. All you have to do is figure out what your discriminant is, and that tells us that it's going to have 2 x-intercepts. So 2 x-intercepts if you are greater than 0. Okay, so this is greater than 0. So we had 16, which is, no, that is one bad looking 16. 16 is greater than 0. Therefore, we had 2 real roots. The next situation, here's an example. They showed you the whole entire quadratic formula. We didn't have to look at the whole thing though. If we just looked at this discriminant part right here that I have in red, you could find out that you get 0. If your discriminant equals 0, you're going to get 1 double root. Okay, so if your discriminant equals 0, you're going to have 1 double root. And the reason behind that is because if I have the square root of 0, it's 0. So I would have this, 2 plus 0 over 2, and I would have 2 minus 0 over 2. So 2 plus 0 over 2 is just 1, and 2 minus 0 over 2 is also 1. And that's why we have the 1 double root. Because adding or subtracting a 0 to something doesn't change it. Because of that fraction. And the last situation, and this is where your algebra 2 will come into play. Someday, you're going to be able to find the real roots, the roots to this, the imaginary roots to this. So if you do the discriminant work, you put your b squared, your minus your 4 times your a times your c. So remember, here's my b, here's my a, here's my c. So they put the negative 3 squared minus 4 times your 1 times your 10. So negative 3 squared minus 4 times 1 times 10. You do that math, you get negative 31. If your discriminant here, like this, negative 31, is less than 0, your parabola is not going to touch the x-axis, ever. Whoops-a-daisy. So you have no real roots. There are no x-intercepts, and that's what an imaginary root is. It's when you don't touch the x-axis. Okay, so if you get a negative, you have no real roots. If you have your discriminant, you do all the math. Remember, you don't do the whole entire quadratic formula. You just do, if I were given this, I would do b squared minus 4ac, so I would do negative 2 minus 4 times my 1 times my 1, because this is my a, this is my b, this is my c. Forgot my squared there. So that would be 4 minus 4, and I get 0. So therefore, that's my discriminant. Therefore, I will only have 1 double root, and it's a real root. 1 double real root. Okay? That's all there is. Remember, homework is day 2. Test tomorrow. Okay, day 2 for homework. Test tomorrow. All right, have a good afternoon or day. Bye.